we don't finish. Precise. Look, let me show you. Easy and important. This is quadratic in front equation. What mean to be quadratic in front? Quadratic in front is, let me use in green color. I like it in green color. Okay, this expression is to the 4th power, and this expression is to the 2nd power. Now, 4 is twice 2. So I take advantage of this property. When this situation happens, I recognize immediately that this equation is quadratic in front. What means that? Means that we can, doing substitution, we can transform it in quadratic. Let's do it. So we are doing use substitution. What is use substitution? Well, you declare A because you want okay, U is equal x squared and y x squared and not x to the 4. You take always the smaller exponent. Okay, now you rewrite the equation. Okay, it's equivalent to the original, but now we're using the auxiliary variable que u. Okay, help me to convert this equation in quadratic equation. This is minus 2u, because remember the definition, okay, I declare u is equal x squared. And this is obvious que es u squared because this exponent is twice this exponent. Do you follow me? Yeah. Do you see that? Now this new equation obviously a quadratic, and any quadratic you are strong solving this using maybe quadratic formula. You declare no. You see que A3, B is -2, C is -1, and you apply the famous quadratic formula. A is minus. The formula have a minus, you know, but B is negative. Double negative become positive together. Plus or minus square root -2 squared minus 4 multiplication by A is 3 multiplication by 6 is -1. Everything inside the radical divided by 2 times 3. Okay, so let's do the operation inside the radical according to the order of operation. Now -2 squared is positive 4, and double negative, I see negative, be careful with the sign, -4 and -1 together is positive 12. Ah, nice, it's 16. And the square root, because my formula contains, you know, the square root is 4. And so far, my answer is 2 plus or minus 4 divided by 6. Everyone follow me so far?
Yes.
Now, I separate in 2 pieces. 2 plus 4 over 6 and 2 minus 4 over 6. 2 plus 4 is 6 and 6 divided by 6 is 1. And 2 minus 4 is -2 divided by 6. You reduce and lower term as -1/3. And we have 2 solutions, 1 and -1/3. Everyone follow me so far?
Yes, sir.
Yeah.
But this is not the final answer. Why no? Because remember, this is the u value. So u is equal 1 and u equal -1/3. And remember, my problem contains the original variable is x. So the equation says solve for x. I need to find the x value associated with this u value, no? But it's easy because I know very well that the connection between x and u is this formula I declared at the beginning. Therefore, I split the paper into parts. I put x squared equal 1 and x squared equal -1/3. Cool. And that moment, I have 2 new equations, that by the way are quadratic equations. Of course, easy because it's incomplete quadratic equation because b is 0. And the super fantastic way for solving this is apply square root both sides. This is x alone is equal to square root 1 is 1, plus or minus 1. Don't forget plus and minus. And here, square root, says x is equal plus or minus again. A square root negative 1/3, que es negative inside, is I know que es imaginary. You know, let me try to manipulate that part. Square root 1/3, well, the I, you know, the implication of the I is I, the negative is I. What is this square root 1 over square root 3? Square root 1 is 1, and square root 3 is square root 3. And you can leave it like that if you want. However, it's much better, in my opinion, rationalization. What means rationalization? Multiplication by radical 3, top and bottom, entonces radical 3 over radical 3 times radical 3 is 3. Okay, nice. Entonces radical 3 over 3. Of course, imaginary. So we have 4 solutions, and this is totally expecting solution set, because the degree is a polynomial equation, but the degree is 4. Look at the beginning, degree 4. Polynomial degree 4, we expect 4 solutions. Actually, it's also quadratic in front. So we take advantage, get quadratic in front to convert using substitution in quadratic equation, solving using quadratic formula. Now, final answer is you put plus or minus 1, comma, plus or minus I, radical 3 over 3. Boom. Done. Any question? No? Easy. Okay. I know it's easy. Okay, now I want to explain another thing. I want to explain the equations. Let me copy here a text. Equation. Let me type it using my keyboard. Equations. And inequality involving VING absolute value. Absolute value. Absolute value. Period. Hey, what's going on? Again, absolute value. Period. Let me try. Okay, we study new idea. Is equation and of course inequality. But the manipulation using absolute value gets a little bit different. Cool. Let me try to understand the new idea. The new idea is, let me recall quickly, of course, absolute value. Absolute value, the notation is a bar like that. Absolute value of 3, for example, is 3. Likewise, absolute value of -3 is also 3. So it's easy to understand because independence is positive or negative, always is positive. But why? What's the reason that always is positive? Well, the reason is because that symbol, absolute value, is like a distance. Let's suppose one more time we have all real number, positive infinity, negative infinity, 0 in the middle, 1, 2, 3, 4, 5, 6, -1, -2, -3, and -3. So the interpretation of absolute value 3 is we have 3 here, and you compute the distance between this number we have inside the bar to 0. 1, 2, 3 step. Likewise, in the -3, here is 1, 2. Hey, I make a mistake. This is this is 3A here. Over there. So it says 1, 2, and 3. Exactly 3 steps. So basically, it's the distance between the number step S. Steps. The distance between the specific number that you put inside the bar and 0. And distance is always, when you're talking about distance is the concept que measure the space or the distance. The distance in between, for example, what is the distance between one city 1 and city 2? That's 2 cities. Suppose que es Honte Hialeah, 20 miles. In that direction, from Honte to Hialeah. And the opposite direction is the same distance, 20 miles. So the distance do not represent direction, represent only the length of the segment que connected to city. This is the idea behind. That is the reason que the actual value somehow eliminate the sign. Clear? Now, for that reason, when you have, for example, actual value x, like equation, you don't know who is x, equal 3, we have 2 solutions. So this is equivalent, one solution gets positive 3, and or much better the or, because it's both, x equal -3. Taking this idea, que es easy, elementary, when you have actual value, any expression equals something, suppose 7, you break it down, this equation in 2 equations. You copy any, but without bar, equals 7. You copy any, again, without bar, equal -7. And you solving this equation, and you solving this equation separately, and we have 2 solutions. Let's do an example. No more blah, blah, blah. Example 1. Suppose 2x plus 1, so 1, actual value, equals 7. Okay, you realize, wow, it's equation que contain actual value, cool. And this is equivalent, that symbol que include a double arrow indicate equivalent, que is more than equal. Equal is equal, this is equivalent, 100%. It's equivalent to write in 2 equations. The first is 2x plus 1 equals 7, positive, or 2x plus 1 equal -7. Oh, some noise. I detect immediately who make a noise. Please, putting off the microphone. Thank you. Now, you split the paper into part. You solve separately this equation. 2x is equal 7 minus 1. I move 1 to the right hand side. 2x equals 6. Divided by 2, both sides, x equals 3. This is my first solution. My second solution would be 2x equal -7 minus 1, get -8, divided by 2, x equal -4. Wow. And we have 2 solutions. Solution set. This equation is 3, positive 3 and -4. It doesn't matter when you write solution set. It doesn't matter what you write first. The order is not important. Ow, noise. Guys, we have 32 students present now. Of course, stay quiet. I don't know. When you have questions, you activate the microphone, but after, no. Okay? But you make a noise. Maybe you don't, but another family you have here in your room making mistake, making noise. Making noise, no mistake, noise. Do you understand the first example?
Yes.
Yeah.
Yes.
Okay. Let's move on to the
Yes.
second example. We have another example that bring me new situation. Suppose absolute value x plus 3 plus 5 equal 12. I always apply this idea. Look, this is the formula or algorithm. But to apply this, we need the absolute value expression stay alone, isolated. The first thing you should do in this example is moving 5 to the other side. Entonces es absolute value x plus 3 es equal 12 minus 5, que es 7. Entonces, so far, my equation is absolute value x plus 3 equals 7. Okay, cool. And I know that this is equivalent to write x plus 3 equals 7 or x plus 3 equal minus 7. Okay, this is x equals 7 minus 3, therefore, my first solution. And my second solution is x equal minus 7 minus 3, okay, minus 10. Final answer. Solution set for this equation, this one, the original, is 4 and negative 10. Easy, right? Important. Isolate the expression que contain absolute value. Without this, you cannot apply this idea. Okay, highlight in green color. Okay. Example 3, bring me new situation. Suppose absolute value 5x minus 3 equal negative 4. Wow. What the hell? No, there's something weird here. Because you explained at the beginning, que absolute value represent this time. And this time never is negative. This time is a positive quantity. Therefore, something I see contradiction. The absolute value, something never would be equal negative 4. This is impossible. This is a stupid equation. Now, what's the answer then? Well, the answer is no solution. It's super easy detecting this because when you see the right-hand side of the equation is negative number, no solution. Okay? Si es positive, yes, two solutions. 1, 2, bam, bam. Do you understand the idea why no solution? Entonces, no solution sometimes in the mathematical language is much better using this symbol. This symbol that looks like 0 and one step is the empty set. It's equivalent. This is the mathematical language, que by the way is equivalent in the common life, common sense, like no solution. It's the same. One more example of the equation. Easy. Super easy. Suppose 7x minus 3, actual value, 7x minus 3 equals 0. Wow, this is different because another problem we see when it's positive number in the right hand side, and you see when it's negative, no solution. It's impossible. Now it's 0. Well, okay, entonces you can apply, professor, this idea que you highlight in green color. Yes, you can. However, 0 have no sign, have no sense to separate into pieces because one is equal positive 0 and other is equal negative 0, but 0 have no sign, so it's completely different. Actually, so we have only one solution, que is 7x minus 3 equals 0. Okay, entonces you solve this equation, you remove the bar, absolute value, yeah, William, yeah, absolute value. You remove the absolute value, and now we have 7x equal 3, and divided by 7, both sides, x equal 3 over 7. Conclusion, what is the fantastic conclusion? The fantastic conclusion is super easy. the solution of the equation that contains absolute value. Because when you have in the right hand side positive number, like this, you expect two solutions. Bam, bam. When you have negative number, no solution, zero solution, no solution. And when you have zero, one solution. One solution. Guys, I'm teaching that part 3,000 times. And some students are doing this mistake. Suppose 2x plus 1, absolute value, equals 7. Now some students, I don't know why, erase the bar and solve this equation. And of course, when you solve this equation, the answer is 3, like that. And ignore the second solution. When you see that, it's conceptually, I put a 0 automatically in this problem, okay? No, be careful, you be careful with the bar. The bar means something, okay? Now, you separate in two equations using the algorithm or the formula that I highlight here in green color. Cool? Any question?
Yes.
No?
I have a question.
Go ahead.
Does it always have 7?
No. It's a coincidence. Equals 70.
Oh.
Come on. Equals 70. Or 700. No. Hello. Okay. Erase or not yet?
Yes, you can erase.
Okay.
Wait.
Oh. Go ahead. Go ahead.
I had so you remember you say how it's no solution if it's a negative number?
Yes, absolutely. Do you understand why?
Yeah, I understand why. So if the 4 was positive, will you be able to get a solution out of that?
Yeah, when it's positive in the right hand side, you have two solutions. And when it's zero, one solution. And when it's negative, no solution.
Okay.
Let's move on to the word of the inequality. It's a little bit more complicated. Not too much, but so we have, for example, the inequality absolute value x less than, 5. This is the less than case. So when the symbol in the inequality is less than case. And we have when it's greater than, no? When it's greater than case. Okay, is suppose absolute value greater than 5. I using the same number, no? Because I want to illustrate the idea behind this. So one more time, I need to understand the interpretation of this. This is my famous or real number line. This is infinity positive. This is infinity negative. 0 in the middle. And we have 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, and negative 5. Okay, the solution of this is the interval. I highlight in green color. Why? Because it's when the distance from the 0 to 5 or negative 5 is less than 5. In other words, is when it's near. Suppose that 5 is a mile and 0 is me, my position. I need to find what, interval belong between 5 positive to the right and 5 negative to the left. Okay, when it's close, it's less than. Because remember, one more time, we interpret that this symbol, including the bar, including the variable, is distance. Totally opposite idea happen here. Because it's too far. And too far, I want to highlight in another column, maybe red. There's that part and that part. Because now this distance is greater than 5 Milo. From me is 0. This is me. Okay, entonces es far, too far. 5 miles, no, 6 miles, 7 miles, or in another direction, -6, -7. Okay. Entonces, how you translate this? I don't understand anything. Well, okay, it's easy. Suppose you have one inequality that contains less than. This is equivalent to write like that. X in between -5 and +5. Wow. This is the algorithm. This is the formula for the less than. Okay, entonces automatically, when you see inequality that contain less than, you don't solve it like that. No. You solve it like this, like a 3-part inequality. You put expression inside and between -5 and +5. However, so you have another absolute value x greater than 5. Oh, this is equivalent, but you cannot express it in one piece. You express in 2 pieces because the red part is 2 interval. You have one interval is x greater than 5. Oh, easy to understand because you only remove the bar, or you copy x less than -5 in the opposite direction. And this is the formula or the algorithm for the greater than. So I detect immediately that you know or you don't know in the test. Because immediately when I grade that, si you see que less than is 1 piece, look, 1 piece. The green part is 1 piece. However, the greater than contains 2 pieces. Make sense? Make sense?
So on the test, when you showing your work, you want us to put the line graph too?
No necessary, mister. I want to show you. In the example, you can see the way I want. Can you solve it? Okay?
Can you do one similar to that?
Absolutely. I have 1, 2, 3, 4. For example, I suppose. Suppose example 1 of that part. Okay, it's inequality. Suppose actual value 2x plus 1 less than 5. Okay, I detected. Oh, it's inequality, no equation. Equation is equal sign, no? Equation is equal sign. I explain how. But no. Now we study inequality. Okay, inequality. Now you see it's like that. This idea. 1 piece. So you copy the expression inside the bar. Without the bar, I remove the bar, and you copy gets in between 5 and -5. Bang! In that moment, I have a compound inequality. Basically, let's call it 3-part inequality. 3 parts inequality. But you solve it easy. You subtracting 1. Remember, my goal is isolate the x. It's -6. That's down to x. This is cancelled. That was the intention. And this is 4. 5 minus 1 is 4 divided by 2. Divided by 2. Divided by 2. It's -3. Less than x. Because 2 divided by 2 is 1. And less than 4 divided by 2 is 2. Bang! However, in the test, always, to don't be confusing, I want the answer. You express it in interval notation. Answer, express it in interval notation. Interval notation is the special notation in which you copy the lower bound, que es -3, comma, you copy the upper bound, que es 2. In this case, you enclose in between parentheses or a square bracket, depending. Suppose another problem that we solve in a few seconds. Suppose that we have equal sign here. Entonces bracket. Bracket -3, comma, 2 bracket. What means that? Let me try to understand this. Oh, no, actually, my problem not contain equal sign. Let me erase that part. Therefore, my answer is this, not this. What is the idea? Well, the idea is clear. You have the real number line. Okay. Infinity positive. Infinity negative. Intentional, I put positive here, but not necessary to put positive, but positive is default. Sn between 2, 1, 2, and minus 3, 1, 2, and 3, minus 3. Now my interval is that interval. Solution. What about the endpoint? Is included inside? No. And the symbolic way to indicate this idea is parentheses. Suppose another problem I want to solve right now. Yes, include the endpoint. How do you know que include or do not include? Depending if our equation contain or our inequality, contain equal sign or not. Supposing in the example 2, Mister, do you understand now? More clear? Yes or no? No? No answer. Suppose this example.
Yes.
Suppose this example, 3x minus 1 less than or equal. Oh, at the beginning, our problem is, it's a combination. So this symbol is less than, that part is less than, that part, equal to. Actually, equal L, equal to. So actually, my problem is a combination inequality and equation. But no, this is okay. I solving, but not separately. No. It's solving simultaneously. Look, I copy the expression inside. I know less than, it's here less than one piece. 11 here and negative 11. This is the formula. This is the algorithm. Now compound inequality, three-part inequality. You adding one, you adding one. So minus 10. Less than or equal to 3x. Less than or equal because that part cancels. 12. Divided by 3. Whole thing. Now remember, when you inequality divided by a positive number, the inequality sign stays the same. So it's minus 10 over 3. Less than or equal x. Less than or equal 4. Entonces, how you express it in the test? Please don't leave it like that. This is correct, but in the test, my test, I specification. I need the answer in interval notation. No interval notation, no zero, but I subtracting points. Interval notation. Entonces, interval notation is easy. You copy the lower bound, que es minus 10 over 3. Separate by comma, 4. It's important, this guy. Lower first, upper secondly. You write completely different, not good. And now the new thing I bring me this example is contain equal sign. Therefore, the endpoint belongs to the solution, and the symbolic way to indicate this idea is using a square bracket. Boom, finals. Cool? Everyone follow me, right?
Yeah.
Yes, sir.
Yes.
Let's do another example. Example 3, no? Yeah. Que es absolute value x plus 3. Let me focus. Plus 5 greater than or equal to 12. Oh, number one thing. I need to isolate the absolute value expression. Absolute value x plus 3 greater than or equal 12 minus 5, que es 7. Okay. Done. Second part. Oh, I detecting this problem is greater than. And greater than, professor explain me que it's two pieces. And how you set out two pieces? Well, remember, you separately, greater than, less than, positive 5, negative 5, but in our example, it's not 5, it's 7, no? And you copy. This is equivalent, 100% equivalent. To write x plus 3 greater than or equal to 7, or x plus 3 less than or equal to minus 7. So the less than, you put negative sign, opposite sign, and you have two inequality, easy, you solving. Is x greater than or equal 7 minus 3 is 4. Cool. This is my first piece of solution. And my second piece is x less than or equal to minus 7 minus 3 is minus 10. Okay, ready? I am ready to represent graphically because I need to understand much better this. Okay, now when you have practice, not necessary doing that. Well, it's the first example, no? So now you put a line. This is positive infinity. This is negative infinity. Using my common sense, this is 0. 1, 2, 3, 4 is here, positive, and this is negative 10. I suppose que here, negative 10, right? Now, this is the main, okay, I put in red color, chop, is that part. Make sense? Include 4 or no? Include 4 or no? Include 4 or no? Yes, no? Yes.
Yeah.
How do you know? How do you know? What is the glue? Can give me information, can include 4.
It has like equal sign.
Exactly. And the symbolic way to indicate that idea is bracket. Okay, and this, let me using another color, maybe green. That part is less than. It's just less than, it's to the left. 11 something to negative 12. And include negative 10, yes, by the same reason, entonces es bracket. Okay, at least I have my solution graphically. But in the test I need, can you write the final answer like that? Actually, it's two pieces. The green piece is from negative infinity, comma negative 10 bracket. And the red piece is for 4 positive to infinity. And the solution completed both. And how we connecting both? Using that symbol can indicate union, capital U. It's not U. It's just mathematical symbol can indicate union. And union is not and. Union is or. Like this conjunction. There's this and this. So any point here, solution. Any point here, solution. Any point here, no solution. No, out the solutions. Cool? You consider
Can you repeat again why we put a bracket on the line?
The clue to understand what's happening in the endpoint is the equal sign. When you see equal sign, bracket. When you see equal sign, bracket. No equal sign, like another example, parentheses. Look at that. Here, no equal sign, parentheses. Equal sign, bracket. Take a look. Out. Where? Here. Bracket. Bracket equal. No equal parentheses. Got it? Super cool.
Yes, thank you.
Any other question? Fortunately, we finished the first part of the chapter 1. Now let's move on to the second part of the chapter 1, that is completely different. It's about the functions. Function. Let me try to explain in detail this idea. I take all my time to explain, slow down, the more clear possible for me, what is the function and what is the property for the function. Now we study one thing, is called function and relations. Functions and relations. Period. Okay, there you go. Function and relation. And make it zoom. Function and relation. Let me explain first of all what is the relation. Because function is more special. Relation, no. Relation is a little bit ordinary. But it's easy to understand. Suppose we have two sets. Wow, it's too bold. Suppose we have, oh, no, I understand. Two sets. A set is the collection of the object. So suppose I call capital letter. It's normally the letter we use to denote the set. Is formed by my students, hypothetical students, and is taking that class, MAC1106. Suppose in the spring 2021. And this is Sally. I separate by comma because this is the element. Paul. It's a people. King. And Luis. Okay, this is my first set. Remember, we have two. We have the second set. I want to call capital Y. Intentionally, I call X and Y. You see why after. Okay, is the overall grade, overall grade, and it's a grade. Overall is overall grade. And this class, no? When they finish, Sally finish, get A, for example. This is a hypothetical example. Right? B, C, D, it's official grade in college, and F. So it's totally legal to get E or K. No, this is not official grade. And when the class is over, we have relation. Relation is association. And between this set. Okay, association, and the association you express set like an order pair X, Y. For example, Sally get A. Excellent, brilliant. Paul get B. King B again. And Luis get A. Okay, so now the element and the relation is formed, you know, by the order pair. Okay, you have two components. The first component belongs to the first set I call domain. Okay, and the second component and the relation is the element belong to the range. This is an elementary example. Do you understand very well the example? So the ordering is very, very important. The ordering is very, very important. So it's completely different relationship to you switching domain and range. It's another thing. It's another crazy. Now, the ordering is very important, and the first component belongs to the domain, que is the first set that you consider initial. And the second component is the element inside the range, que is considered like a second. However, what about the function? What about the function? Function is a special relation. Let me try to understand the definition, it's very confusing, functions. And after we see, I promise, okay, we see example to understand more clear. Function by definition is, it is a relation okay, exactly we see before, such that each value or element, whatever you want, in this case element, because is each value in the domain, okay, the first set, is associated with only one value in the range. Okay, so now the most important word in this definition is this. Only one. This is the idea. It's a no ordinary arbitrary relation. No, it's a special relation in which you select only one in the range. Let me try to understand because it's very confused. I don't understand anything so far. Clarify. Okay, suppose X again. Well, X I call the set of the domain. Okay, it's an input. 1, 2, 3, and 4. 4 elements. This is my domain. And Y is another set. Okay, it's formed by no number anymore. It's letter A, B, C. A, B, C, and D. This is my range. Okay, so I want to set up different relation, and you help me to understand if satisfy the condition of the definition for the function or not. For example, relation 1 is 1, A, you associate 1 and A, comma, 2 and B, comma, 3 and C, comma, 4 and D. What do you think? It's a function or no? No, professor. I am totally lost. Yes, she said, yeah.
Because the domain have one in the range.
Let me see. Let me try to understand. I propose you one idea because sometimes it's confused about that. 1 is associated with A using the arrow diagram. 2 is associated with the B. 3 is associated with the C. And 4 is associated with the D. Okay, cool. Entonces es obvio que we are in front the relation que es 1-to-1. 1-to-1 what? 1-to-1 function. Because, and remember, the most important in the definition is this one. That the first one is not important. The one in the range. It's a definition. Okay, now I want to complicate a little bit your life. Relation 2. Relation 2 is similar, but no equal. 1, A, 2, B, 3, B. I change something, and 4, A. What do you think? It's a function or no?
Yes.
Absolutely. Absolutely. You are right, mister. Okay, entonces, suppose que you don't know. Okay, no problem. Let's do in the arrow diagram to clarify this idea. So 1 is associated with the A, 2 is associated with the B, 3 is associated also with the B, and 4 is associated also with the A. Something like that. Entonces es no 1-to-1, pero es many-to-1. Many-to-1. But the important part is not the first part, it's the second part. It's 1. See, this is one satisfied perfectly the definition for the function. So we have function. Bang! Okay? Now, I want to complicate more. Relation 3. Relation 3 is 1, A, comma, 2, B, comma, 3, C, comma, 3, D. What do you think? Is a function or no, that relation?
It's not function.
It's not a function, but I need to understand why.
Because 2 values from the domain correspond. Because the domain It corresponds to two different values of the range.
Eso.
Domain.
Very well, very well. Let me try to visualize. 1 corresponding with A, 2 corresponding with the B, 3 corresponding with the C, and 3 corresponding with the D. This is the big problem. This is one too many. One too many. One too many. Go ahead, go ahead. One too many. This is the complication. The complication is this part. Many, 2 associated with the 3. Therefore, the answer is no function. Okay, the answer is no function. This is no. This is yes. Yes, it is. And it's yes, it is. So some students have a question. It's clear or no? Okay. Yeah. Entonces, conclusion. Super conclusion. Super conclusion is, well, 1 to 1 is okay. Many to 1 is also okay. Because the reason is because we have 1 here. However, 1 too many, no. It's not. Okay. Now, of course, many too many is super crazy, no? It's not okay. So this is important. 1 here and 1 here and the range, according to the definition for the range. Let's see example, and you help me. Another example, and you help me to understand this. Suppose que is given in example 1. This was the motivation example. This is the actual example 1. Suppose relation 1. They need to determine if this relation is a function or no. And more, please let me know what the domain and range. 2, 3, using just number, no letter. 4, 1, 3, -2, and 2, -1.
It's not a function.
It's not a function. Let me try to analyze the arrow diagram. 2 associated with the 3, 4 associated with the 1, 3 is associated with the -2, and 2 is associated also -1. That's clear. Case 1 too many, no function. Okay, and you can help me to determine what the domain and range. Remember, domain is a set of formed by the value of the first component, and the range is the value associated with the second component. Domain is 2,
2, 4, and 3.
2, 4, and 3.
And the range is going to be -3.
Important. I want to. I know that you know when some value is repeated, not necessarily 2, 4, 3, 2. No, because it's repeated. So this is important property of the set. 2 important property of the set. The set is no repeat value is possible. O sea, es suppose María, José, María. No, illegal. Because María is inside the set. It's the same María, no? Okay. And the ordering is not important. So no repetition for the element in the set. And the order is not important. So the set María, José is equal José, María. It's important property for any set. And what about the range? 3,
1, -2, and -1.
We have 4 elements in the range. We have 3 elements in the domain. Okay, one more example. I suppose that you feel strong with this idea. Relation 2. Relation 2 is 2,3, 4,3, 3,3, wow, and 5, -1. What do you think? Is a function or not? And where's the domain and range?
Okay, it's a function and domain is 2, 4, 3, and 5, and the range is going to be 3 and -1.
Good, perfect. So she said, okay, yes, it is a function. And domain is 2, 4, 3, and 5, no?
Yes. And
However,
the range was 3 and -1.
Only two guys, 3 and -1, because 3 are repeated 3 times in this.
Yeah.
Excellent, beautiful. Everyone follow me? Everyone agree? Do you understand very well? Do you remember the high school?
Yes.
Okay. After that, I want to explain a fantastic way to determine si one relation is a function or no when you have the graph. When you have the graph, I want to draw 4 different graphs. This is x-axis, this is y-axis. And we apply one thing, one test, que es called vertical line test. It's a test that allows me to understand if the graph belongs to the function or not. Suppose one function like that. Now this arrow guy indicates also that this, it's a one piece. Actually, it's a parabola like that. One is infinity in that direction and infinity in another direction. The easy way to indicate this, you put an arrow que indicate also que contiene forever in that direction. No? Okay, the second graph is this. The third graph is different, it's like that. It's another parabola like that. And it's a circle. It's a circle. Of course, the x-axis continue here. X-axis. Okay, so what is the idea behind vertical line test? You are doing hypothetical vertical line in any point. See this vertical line cross in only one point is a function. Yes, it is a function. Here, exactly the same. In only one point. Of course, in any vertical line crossing one point to the curve, que es red color. In this case, no, 2 points. Maybe in this point it's only one, but it's only particular. In the general, no. The answer is no. No function, the answer is yes. It's a function, and here, of course, is no. And what is the idea? What is this? Is the same idea? Yes, it's the same idea, because actually the x value, que es this, corresponded with the 2 different y. I call y1, I call y2. Let's see, 1x is associated with the 2y. It's obvious que it's a contradiction with the definition for the function. Cool? Cool? So in the test, I give you one graph, and you need to investigate if it's a function or not. So see, this graph belongs to the function or not. So the only thing that you should do is apply the vertical line test. Si pass the test, it's a function. Si fail the test, it's no function. Okay? Okay, hey guys, is there the WhatsApp link? Because you have WhatsApp group, no? Okay, so now let's do a similar idea, but no graphic. Suppose there's no graph anymore. And we have equation. So the information is given in our problem is no graphic. It's equation of the one hypothetical relation. I need it 2 pieces. Okay. Isabella, go. Equation. So the equation is giving. Okay, so basically the idea is identify a function by its equation. Now the information gets given as equation, and you need to investigate see this equation gets given and the problem belong to the function or not. This is a little bit more complicated, more confusing. Why is confusing? Because actually we have two different ways to express the equation. We have the famous implicit form, and we have the explicit form. Immediately I explain the difference between implicit and explicit. The implicit and explicit is two different ways to express the equation is given at the beginning. Suppose this 3x plus y equal 5. So we suppose, guys, x is our independent variable. X belongs to the domain, and y is dependent variable belong to the range. This is convention so far. But in this equation gets given in the test, is no isolated x and y. So this is the reason que es implicit. And implicit is synonym to be confusing. Not clear. Now to clarify, you need to express it in explicit. Explicit is super clear. What should I do? Why don't you isolate the y? So y alone, I move, for example, minus 3x to the other side is minus 3x plus 5. When the y is isolated, is explicit. And explicit is the correct way to express it to start any analysis. Of course, in the test, I give you the equation in crazy way, not necessarily explicit. I put confusing. And you manipulate, isolate the y que es explicit. Suppose another example. X squared minus y equals 6. This is implicit. However, I write the y isolated. For example, I move x, y to the right hand side, 6 to the left hand side, subtraction, and after you reverse it, because I want to express the y in the right and the left hand side. So do you understand the manipulation I did that? Suppose x times y equal 4. It's implicit. Now y is equal 4 over x. So you divide it by x both sides. In this case, if you want, cancel out that part. If you want to solve for y. X, this is the beginning, is given like that. X times y equal 4. Sound weird, this, but it's easy. It's easy because one equation is given in my problem. However, you cannot start if you are not sure 100%. Can you write in explicit form? Suppose example, a couple of examples to understand this very, very well. Example 1 of the equation. Determines it's a function or no. Suppose y equals x squared. Wow, it's given this. My question is this equation is explicit or implicit?
It's explicit because it's
It's
Explicit.
explicit. Entonces, to be ready to analyze. Entonces, what is the analysis? The analysis is, bueno, 1x, que you define one value, arbitrary value, give me only one value of the y. For example, suppose x equal 3. Give me y equal 9, because actually the operation is square. 3 squared. Let me do it step by step. 3 squared and 9. And this happens for any value. So 1x, give me one value of the 1. Therefore, it's clear that it is a function. Yes, it is a function. However, let me put a counterexample. Example 2, in which, for example, you have this, que es similar but not exactly the same. Suppose x is equal y squared. Question number 1. This equation is expressed in implicit or explicit?
Implicit.
Implicit. Very well, because y is not isolated. And what should I do? Well, I need to solve for y. To solve for y, let me try to copy here. You apply square root both sides. And square root x equal y, but I forgot plus and minus. Okay, I guarantee you 100%. Okay, this expression is equivalent 100% with this, if you include plus and minus. Now, the crucial moment. It's a function? No. Why no? Because one value of the x give me two values of the y, y1 and y2. And who is y1? Positive radical x. And who is y2? Minus radical x. Example, numerical, to understand much better. Suppose que x is 9. Give me two values, que is positive 3 and negative 3. Because the square root 9 is 3, but you have plus and minus to answer. Now we have in the case one too many. Therefore, that function is given at the beginning, this one. Okay, by the way, it's equivalent 100% of this. It's no function. No. No, it's no function. Of course, there are more complicated examples, but I don't want to complicate too much that part because we have a lot of important things to cover today, no? Okay. Any question? What part is confused? No? Everything is clear? No question. Erase the board. Okay. Let me study now function notation. Function notation is super useful. Function notation. Super useful in algebra. What is the typical format for the function notation? Well, the format for the function notation is I forgot M, no? Function here. Let me try to fix. I don't know if I can fix. Well, I can using the pen, no? Function notation. Okay. So now, what's the idea behind function notation? The idea is you define one name of the function. The classical name of the function in algebra are f, g, h, and so on. One letter. Sometimes we use in two letters, like lm, we study in the next chapter. And sometimes we use in three letters, log, sine, and trigonometric, cosine. So basically the name of the function in function notation is one letter, two letter, or three letter, no 4, no 5. Okay. And you, for example, you open f, you open parentheses, and you put x, okay, x represent the value of the domain. By the way, these parentheses do not indicate multiplication. No. A symbolic way to indicate that the element that you plug it in here represent value of the domain. It's totally symbolic, no multiplication. It is totally illegal, right, like that, without parentheses. It's crazy. Nobody understands this. And this is always equal to y. So y and f of x is equivalent. This is the beautiful idea. But what is the reason, Professor, that I need to use in a new way? Well, because this new way function notation open the door to any possibility to plug it in easy, to make transformations that we study not today, we study next class, transformation in detail. Okay, so now suppose one hypothetical example. Suppose that I want to evaluate the function into, well, I define one function, first of all, is x plus 6 divided by, so you can call, if you want, like that, y equal x plus 6 divided by 2x plus 3. Okay, I understand very well. However, another possibility is declare that no y anymore is f of x. And this open the door to understand transformations. Suppose I want to evaluate a 2. So you replace x for 2, so now is 2 plus 6 over 2 times 2 plus 3. And you apply the order of operation. 2 plus 6 is 8, 2 times 2 is 4, and 4 plus 2 is 7, 8 over 7. Bam! Ah, this is the easy case, Professor, when you plug in only one number. Okay. However, we have different transformations. For example, you have reflection. Okay, I don't want to explain in detail. Only I want to explain the algebra, but not the interpretation, the geometric interpretation. No. Reflection. What is the reflection? When you have the function given at the beginning, this one. I want to make reflection. Reflection is you replace x for negative x. It's reflection. This is minus x plus 6 divided by 2 times minus x plus 3. Leave it like that? No, it's ugly. You copy 6 minus x, much better to put it first, the positive number. And this is 3 minus 2x. Bull, this is the reflection of this. And your moment, I promise, I want to explain the interpretation. What is the relationship between this and this? Okay, by the way, that reflection I did was about y-axis. But okay, you accept this. You don't understand very well now. Now we have another reflection. Okay, reflection about the origin. Let's call it the origin. The origin, remember, the point 0,0. So you are doing reflection with respect to the origin. Well, we are doing different. We are doing a minus. You put a minus. Remember, minus is always a reflection, but the minus is inside the parenthesis or outside the parenthesis. Okay, you put a minus outside the parenthesis, a reflection about the origin. You put inside a reflection about the y-axis. So it's easy. You put a minus here, and you copy the original, and that's it. This new expression includes the minus and the from. Okay, by the way, you can express it like that. You know, minus and the fraction. You can put in the middle, in the front. Oh, why no? Why no? You put in the back, in the top, minus x plus minus 6 over 2x plus 3. Or in the bottom, why not? It says x plus 6 divided by minus 2x minus 3. This expression, guys, this expression and this expression are equivalent and represent reflection. Minus outside, reflection about the origin. Minus inside, reflection about the y-axis. Okay, not bad. Now I have another kind of transformation that is, suppose this is f x plus 2. Ooh, it's a you adding 2 inside the parentheses, and this is the horizontal shift. I promise next time we study in detail transformation. Horizontal shift, vertical shift, stretching, compressing, everything, and detail, and detail, and detail. Horizontal shift, shift. Okay, horizontal shift, in this case, 2 unit. I'm moving 2 unit, but horizontal, we have 2 possibility, to the right or to the left. And vertical is upward, downward, but in this case, horizontal, because it's adding 2 inside the X. So the motion of the graph is horizontal, in this case, to the left. Yeah, I want to prove, no now, next time. But it's easy. Algebraically, I guess my goal now is easy. You take the original expression, the original expression, get this, and you replace x for x plus 2. So says x plus 2, no x anymore, plus 6 divided by 2, x plus 2 plus 3. Okay. Leave it like that? No, of course, no. This is ugly. I try to do my best here. This is x plus 8. We combine 2 plus 6, and you distribute here 2x plus 4. You go 2 times 2 is 4, 2 times x is 2x plus 3. One more time, we combine like 10 is x plus 8 over 2x plus 7. And this is my new expression, the ID transformation. What kind? ID horizontal shift. 2 unit, in that case, is to the left. Okay. Another application of the function notation. Oh, important. Extremely important. We use it every day to find intercept. Suppose I need to find y intercept. Y intercept. What is the formula? I don't remember the formula for finding y intercept. Oh, I remember using function notation. You evaluate 0. This is the formula. You plug in 0 here. In our specific function that we start at the beginning is 6 no 6 no 0 plus 6 divided by 2 times 0 plus 3. And the top stay only 6 and the bottom stay only 3, and 6 divided by 3 is 2. And the point is the point 0, 2. It's a y intercept. Bam. And what about x intercept? It's similar. I promise I want to use this frequently throughout the course. Okay, what is the formula? I don't remember. One of the formulas similar is you put f of x equals 0, and you solving this equation. This is different because it's just plugging in arithmetic part. This is no, this is algebra, because you enforce it to be 0. So actually, the thing I did was y equals 0. Okay, so in our specific example, okay, we start at the beginning is, let me try, x plus 6 over 2x plus 3. I copy f of x original equals 0. Oh, nice. And when it's equals 0, the responsibility to be 0, that fraction is only the top part. Yeah, I can delete mentally that part. And my equation is reduced like that, and x is equal minus 6. Now the x intercept at the point minus 6, 0. Why 0? Because I suppose y 0. This 0 is this 0. And this x is minus 6. Get this. Do you want to see another example of the y intercept and x intercept, or is clear this idea? I bring another. Okay, maybe it look like interesting. Guys, I explained too fast or I explained well?
You're good.
Good, okay. Now, suppose another example. Suppose it's given one function and function notation. Let me try to use an absolute value, because we studied today absolute value. Entonces, I remember very well. Absolute value x plus a. And what is my goal? What is my goal in this example? Find y-intercept and find x-intercept. What is the formula for a y-intercept? I don't remember. It's evaluate 0. And what is the formula for the x-intercept? You take the function and you enforce it to be 0. Let's do it in this function. fn0 is actual value 0 plus a. 0 plus a is a, y actual value a is a. And the point is the point 0, 8. And the x-intercept it's more complicated because it's equation. So you put actual value x plus 8 equals 0. Oh, but it's easy because I remember that when you have inequality que is equal to 0, we have only one solution. So what should I do? Well, you remove the bar and solve for x, que es minus a. And the point is minus a, 0. Suppose I want to do quickly, of course, the graph of this. This is the x-axis. And this is the y-axis, 90 degrees. Bam, bam. Excellent. X-axis, y-axis. I plot that point. That point is 0,8. 1, 2, 3, 4, 5, 6, 7, 8 here. Bam, 0,8. And minus 8,0 here. 1, 2, 3, 4, 5, 6, 7. Minus 8 here. Minus 8,0. I have 2 points, and the graph, I anticipate you, can look like that. It's a line. And the actual value graphic always have 2 branches. One branch to the right and one branch symmetric to the left. This is the graph that corresponds with that function. The thing I using in this example was y-intercept, is the point in which the function crosses the x-axis, and x-intercept, is the point in which the function, in this case, no touch the x-axis. Cool? Okay, that's it. I suppose que no. We have another application that I want to discuss because it's important, because you can see in the test. There one application. Erase the board or no?
Yes, you can. Yes, you can.
Yes. Guys, you copy. Hey, what is this girl? It's a girl or boy? Okay. Okay. Let me try to explain another application of the function notation. Let's call it difference. Difference question. Different question. What is that? It's a formula. I want to explain like a formula, and I want to explain after, like a curiosity interpretation of this. But this is important because in the test you see one question like that. Okay. Suppose that one function is given. F of x equals something. Equal x squared minus 5x plus 6. Okay. Yeah, I need to compute different question. Entonces, what is the formula for the different question? The formula is, you take the function that's given in the problem, you apply one horizontal shift, so you're adding one number. A hypothetical is h. Who is h? I don't know. Subtracting the original and divided by h. This is my formula. That's what is the goal. The goal is one function is given. I need to apply on that function this formula. What is the interpretation? I promise I want to explain, but no now. So we're solving step by step. What is the step one? Let me use a record for step one. Step one. Who is step one? That part of the formula. Okay, so now I copy fx plus h. In function notation, this is equivalent to say you replace x for x plus h. Entonces x plus h squared minus 5 paréntesis x plus h plus 6. Do you follow me so far? Yes or no?
Yes.
Yes.
Yeah. Leave it like that? No. I need to manipulate a little bit. How you manipulate? You apply FOIL because it's a multiplication to binomial. No? And when you apply FOIL, x times x is x squared. X times h is xh. H times x is the same. I copy in the same order. And h times h is h squared. Okay, this is that part. Now apply distributive, minus 5x minus 5h plus 6. Boom! And this is the first part of the formula. Okay, this is just the beginning. Now I'm moving on to the step 2. What is the step 2? Step 2 is that part, in which you're subtracting the red part I have in my hand. You're subtracting the original. So I copy x. Oh, no. Let me copy correct. You are doing that part. F. No. Blue, coño. Blue. Blue. F x plus h minus f of x. In our specific function, that part is x squared plus, well, actually, this is possible combined like term, 2xh plus h squared minus 5x minus 5h plus 6 subtraction f of x. Who is f of x? The original. And subtracting polynomial, obviously you change the sign, opposite sign, completely opposite sign. Entonces x squared plus 5x minus 6. Do you understand this?
Yes.
Cool. Now a lot of people cancel out in that moment. All we happen, cancel out x squared, cancel out 5x, positive and negative, positive 6 and negative 6, and stay alive in the second step. Two xh plus h squared minus 5h. Okay, we almost finished. Now I go to the last step, que es whole thing, the green part. Step 3, que es easy, because the only thing you should do is divided by h. So you take f of x plus h, ID in the step 1, subtracting f of x, ID in the step 2. Now the new part is divided by h. But it's easy, because it's just polynomial divided by monomial. Okay, exactly the same, divided by h, divided by h, divided by a. You split in different monomial, and this a is cancelled, and this a is cancelled, and this is cancelled, but only one. So take 2x plus h minus 5. Bam! And this is the final answer of the famous different questions. You want to see another example? Or is enough?
Can I have another one?
Yeah. Of course I have, and after I want to discuss in the interpretation there. Okay. Or let's discuss in the interpretation first. What is that? Interpretation of the different questions. Guys, what is the reason it's important in calculus? student que need to take calculus, you see the different quotient from the first day. Suppose we have function. We have the graphic. Let me explain the interpretation, geometric interpretation. This graph represents my original function is given. Y equal f of x. And you pick one hypothetical point here. I want to call x. And this is f of x. And one distance here, okay, I want to call h. This is the idea for the h. This is x plus h. And you evaluate here, bam. And this is the function f evaluating x plus h. So this part in the top part of the formula, you have one segment que es f of x plus h minus f of x. Actually, this is that part. This segment represents that part. And this segment represents h. Oh, entonces I understand now. This is like a, suppose que I connecting by the line, straight line, the point I suppose hypothetical at the beginning, x and x plus h. And this is the secant line. It's the secant line, guys, because any point crossing in 2 points is called a secant. Remember, secant suppose a curve, we have 2 points. This is the line, secant line. See, it's tangent line, touching only 1 point. But no, in this case, secant 2 points. Now, this is obvious that this is like a right and wrong. Okay, entonces, what is the interpretation? The quotient, different quotient. Is the slope of secant line. Okay, connecting to arbitrary point that you define at the beginning. Okay. So you want another example? This is the interpretation. Okay, I never asked you about this. It's your culture. Suppose que es easy. I give you one function, easy. Suppose que es 3x plus 2. Wow, it's linear. It's linear. But you apply the formula again, step by step. Step 1, step 2, step 3, but I do it fast. You evaluate f and x plus h. Is 3x plus h plus 2. Let me erase that one. You apply distributive property, 3x plus 3h plus 2. Cool. Now you're subtracting the original function. Okay, so the original function is, wow, 3x plus 3h plus 2 minus 3x minus 2. And this step always cancel out a lot of things. Cancel out 2, cancel 3x, stay alive, only 3x, no? No. Mistake. Okay, I underestimate this. 2 is cancel, and 3x is cancel. And stay alive, down, 3h. Okay. Now what is the last step? Divide by h. And divided by h means divided by h here. And the answer is 3. And it's no surprise. It's 3 because 3 is the slope of this line. So actually, my function is a line, and the quotient, different quotient, represent the slope of the secant lines. You in one line, you pick 2 points. It's obvious que this is right and wrong. It's obvious case. Guys, unfortunately, the time is over. No, the time flies. We continue on this next Wednesday. The function part gets super long and complicated. And you try. Remember, I cannot help in the test. No, the test is your test. Of course, you can interchange with the other student. This is totally online. I understand this. However, any question you have about the homework, I checking that some students start doing the homework. However, not all students start the homework. Okay, remember it's due or at least technically next Monday. It's due both tests. See, I extending, I make a decision maybe Wednesday, depending on the dynamic of the class. Okay. Okay, professor, I have issue. Or any issue that you have, you communicate with me by email, guy. Okay, any problem here, we discuss with me only mathematics. Okay, any issue that you have, you communicate. I am human, I understand maybe, you know, depending. You explain me, I understand.
Professor.
Uh-huh.
Are you sending the test through the email?
Yes. Written test, send me the answer by email. Guys, I need the answer in detail. You write, well,
Okay.
you write only the final answer, 0 for you. So I need to see the word in detail. Immediately, guy, I detecting see you're writing the answer right reading have no sense or no. Okay. Clear? Clear?
Yes.
Guys, bye-bye.
All right, Professor. See you later.
Bye. Thank you,
Thank you,
Professor.
Professor.
We continue Wednesday. Dale, go ahead.